Hi everyone, I'm Irene. As Kev said, I am a third year computer science student at the Uni of York. I've basically done in the past a bit of AI. I've worked as in the AI computer vision group at the uni, just an internship. And then for this year, I basically chose all my modules to be AI. So I thought to choose to share a bit of my knowledge, and maybe I can tell you something that you don't know about it. So we are going to start with a quick introduction of AI and machine learning, because often people just interchangeably call them the same thing, but they're not really. Go through some quick algorithms, application, and then I'll show you a very quick code demo that I hope works, because code demos live. So yeah. So AI is basically a computer that performs tasks that are usually performed by humans. This can be driving your kids to school, choosing what you want to eat for lunch, maybe hugging someone when they're sad. And this is what AI is. We call this strong AI. There are two types of AI. This is strong AI, and then there's weak AI on the other hand, which performs only one task. It performs that one task really well, but it's only that one task. For example, Alexa and Siri. I wouldn't even say they perform it too well, but I guess they're performing it a lot better now. But they can only perform that single task. So even within AI, we've got strong AI and weak AI, which are two very different things. Then we have machine learning, and machine learning is pretty much the ability of an algorithm to improve through experience. So we have different groups of algorithms between machine learning, but as you can see, machine learning and AI are pretty much different things. So AI and machine learning have been around for a very long time, but in the past years, as you can see, there's been a very big increase in these topics. And as I said, it's not because they've just been invented or anything. It's just mainly because computers have gotten a lot faster, and our ability to interact with AI has gotten better. So in the time, our computer performance has increased a lot, and the data that we have available has increased a lot as well, which means that now we can use deep learning and machine learning. And deep learning is a very cool topic that I don't think I have any time to go into today, but yeah, it'd be interesting to have a talk on deep learning as well, but we're gonna look at machine learning today for most of the talk, I think. So yeah, just a quick recap. As I said, the fact that they've been around for a long time is just there has been a lot of hype around it recently, because there is a lot more data and computers are faster, so able to actually process the outputs in a reasonable amount of time. So we're gonna very quickly talk about a few groups of machine learning algorithms and how they're divided. Initially, we have supervised and unsupervised algorithms. In supervised is basically when you have an input and you know the output. So you can basically train the algorithm by allowing it to learn something that you already know what the output is going to be. This might be emails, for example. You kind of have a set when you already know what is a spam email and what isn't. So you can basically, the algorithm can learn to then reproduce and learn how the data looks like when it's spam or not spam. Whereas with unsupervised, it pretty much learns by itself. So you give it a set of data, and then the algorithm has to find some kind of pattern or something that distinguishes one data point from another. So going into a bit more detail about supervised learning, today we're just going to look at classification and regression. So if you imagine that you have a box of fruit with apple, pears, and whatever, oranges and stuff like that, classification algorithm, basically you show it an apple and then you tell it that it's an apple, and you do the same for every piece of fruit. So you would say this is a pear and then this is an orange, and for every piece of fruit that you're going to teach it, you show it that, and you do it for a lot of fruit, I would say. And then at a certain point, when you show the algorithm some fruit that it wasn't in the test set, if that wasn't in the set that you've already shown it, the algorithm will be able to tell whether that's a fruit, whether that's an apple or a pear or an orange, and then just decide which one it is. So this is actually done for emails. So in emails, you've got spam and not spam. And over time, you've shown an algorithm what is spam and what isn't spam. And at that point, is now able to recognize spam and not spam. So yeah. Then we have a regression. A regression is basically completely different. Rather than teaching classes like we've just done, you're basically trying to find a function. So you give it an X, which might be, I don't know, for example, how much time you've studied for a test. And then you've got a Y, which is, for example, the exam, the test result or the exam grade that you got. So you can basically plot a line trying to understand what grade you will get if you study a certain number of hours if you study a certain number of hours. So rather than finding classes, is finding a function that can be applied to data that when you then present a point, it's going to be able to find where that point is located in the line. Then we go into the unsupervised learning. And one algorithm in unsupervised learning is clustering. So clustering is kind of different from classification. It kind of sounds similar, but as we said, it's unsupervised learning. So we don't really know, if we think back to the box of fruit, we don't really know what apples are and what pears are. We just know that we have a box of fruit with items that look all different to each other. So as you can see, it's probably gonna, if we say that we've got oranges, I don't know, lemons and apples, okay? So it's gonna divide the oranges and the lemons and the apples based on characteristics. So for example, color and size and texture of the skin and stuff like that. So once it's divided them, it's going to keep trying to reduce those points. So to reduce these ones that are outside the clusters. So it wants to assign every point into a cluster. And as you can see, there are still a few ones that are left out, but that's just because there are some points that you literally can't assign to any cluster. For example, if you have oranges and lemons, and then I give you a tangerine has a size in terms of like bigness that is closer to a lemon. So it's not an orange, but at the same time, it's the same color as an orange. So you might have a point around here between the cluster of lemons and between the cluster of oranges that where that tangerine is going to be classified in, because it's not either of the clusters. So as I said, it's not about forming something that you know necessarily these are the clusters of oranges. It's mainly about getting data all together, data that looks the same all together. So yeah. We are going, well, there are so many applications of AI that I can't really explain them all in like a simple talk, but I just wanted to show you a very quick few ones. There's face recognition, of course, that probably a lot of us now have on our phones or computers, and it's really nice not having to insert your password. Self-driving cars, yeah, this has been such a hot topic recently. It's definitely one topic to have a long ethical talk about it, because there's so many things to consider about this, both technically but also ethically. It's really interesting as a application of AI. Netflix basically uses AI amongst other things, but also to recommend you things that you might want to watch based on your history. So if you always are a person that always watches comedy, you're not gonna find on your recommendation like a horror movie one day just like that. It's going to keep you recommending comedy because that's what you've been watching and they want you to enjoy your time on the platform. I'm not sure whether this is a proof of concept, something that has happened already, or something in the middle. It's basically an app that allows you to order a coffee completely online, just talking to a chatbot. which sounds really easy, but then when you start looking at the processing of human language, it's actually really hard for machines to understand what we mean. For example, if you can see in the first line, here there's a question mark missing. And for us, it doesn't really make any difference. But if you ask an algorithm to distinguish whether that is a question or not, it will struggle probably at the start if you haven't shown him enough examples where there is a question mark missing. So it sounds really easy because it doesn't look particularly hard, but it's really hard to actually program in all the variables that all the different types of way a person can ask the same question. And then, yeah, of course, Google, for the many things that they do, they recommend you things based on your past searches. So if you have a dog and you've been searching a lot of information about dogs and maybe dog food and stuff like that, if you're gonna type pet food, it's not gonna show you, I don't know, a bird food for the first finding. It is going to show you relevant things based on your previous searches. So yeah, this is a graph which can be described as very, very messy, probably not to be put in a presentation. I wasn't gonna include it, but then I thought about it, and it's pretty much very similar to what the actual process of machine learning algorithm is, which is very, very messy. When I started, I thought it was gonna be a straight line, get your data in and not even process it, just send it to the algorithm and you'll be fine. Something will come out. It turns out that it's not really like that at all. You need to do a lot of processing of the data. The quantity of the data matters, but not if the quantity doesn't have a lot of quality. So you need to find basically a balance between having a lot of data and a lot of data that tells you the same thing, which is really easy, but at the same time, when you're trying to just use a data set, really hard at the same time to allow you to find one like that. Then you need to normalize it. Then you need to think about sets that you're going to use for training and sets that you're going to use for learning and sets that you're going to use just for testing whether the algorithm is actually good or not. And maybe it turns out that half the way you've been planning to use a model that doesn't actually model the data in the way that you want it to. So you need to start all over again and get your data in a new format. Yeah, it's really messy. So that's quite kind of the reason why I left it in. So I don't know how we're doing with time. Kevin, we're okay?
Yeah, you got like about 3 minutes.
All right, cool. I'll show you a very quick, or maybe I won't. Okay, fine, cool. All right, I'll show you a very quick demo. So for anyone who doesn't know, this is Google Colab. And Google Colab basically allows you to run any machine learning model as long as you've got a Google account online. So you basically use their a cloud, basically you connect to it, and then they give you some amount of RAM and some amount of disk space to run your machine learning algorithm in, which is really good. Like even with very hard deep learning neural networks, it can still work pretty well. So really quickly running through the code. If we think about this, I basically want to predict whether a student will pass or fail an exam based on the amount of hours they spend studying and what they've got in their like midterm grade, like one of the tests that they did in like halfway through the course. And we have a student that studied 5 hours, but then got 40 in the midterm grade, and then a student that studied 7 hours and then got 100. We can kind of already see who's going to pass and who's going to fail, or like the pattern in the data, but let's just go with it. So I initially just copied in the variables as they are, just to make it clear that I didn't make anything, like there's no magic around here. And the targets. So basically, as we know, these are the things that we already know. This is a supervised algorithm, and this is the thing that we're trying to predict. Then we combine all the information that we know into just one single variable. So I'll try to I'll print it out so it's clear. Yeah, never mind. Okay, cool. It's okay. So as you can see, I just like literally merged in the two variables that we have to understand whether we're going to pass and fail. And then this is, and then we basically initialize, I set it to Y just to make it clear. And these are the things that we want to predict. So this is the student that they spent 5 hours studying and got 40 on the midterm grade, and that's the other student. So we initialize a logistic regression, and I call it classifier because although the logistic regression isn't technically a classification algorithm, it still predicts which class a certain data point is in. So I won't talk about this today, but if you look at this algorithm, it's not classification, it's mainly a regression, but yeah, we can still use it for this purpose. Actually, this is the main purpose of this. So as you can see, it's really easy. We basically fit or teach the algorithm these data points using the X as the things that win the features basically, and the Y as the final grade that the exams the student got. And then we predict for each student what they're going to get. So if we run this, yeah. So we can see that based on this data, which is not a lot of data, the algorithm predicts that a student studied that amount of hours, failed, and then this one passed. So as you can see, there's not a lot of data that we train the algorithm on, and it can definitely be improved. But even with a simple data set, we're able to make a prediction. So yeah, that ran out fine. I put here some resources that will allow you to get started really easily. As you can see, I put in Google Colab. This blog is amazing. You can just start in right away. They get you started from the right start. This is a project when you have a bit more information. It basically allows you to predict, I think, whether people on the Titanic would have survived or not. And there is Kaggle, where you can do competition and just get data sets, and a lot of courses from these people. And I think I probably run out of time, so I don't know whether we have time for questions, but here's my Twitter handle if we don't. And yeah, thank you.